Jai Hind. Myself Pushkal Kumar Shukla, Assistant Professor in Computer Science Department at Ajay Kumar Garg Engineering College. I will discuss today Introduction to Set Theory. This is a very important topic in a discrete structure and theory of logic. The content which I will cover here are definition of set, a set representation, a standard notation, cardinality of a set, types of a set, partition of a set, Venn diagram, operation on a set, and algebra of sets. Now, the objective of this set theory is, sets basically is used to define the concept of relation and function. The study of geometry, sequence, probability, etc. requires the concept of set. The students will demonstrate the ability to use set to codify a mathematical objects. The students will able to represent using set builder notations, give example of finite and infinite sets, build new sets from the existing sets, and determine whether two sets are equal or unequal. The objective of Introduction to Set Theory is all these. Now, what is set? What is set? Basically, set is well-defined collection of distinct object of similar type, same type. Suppose, for example, set of rivers of India. So, set of rivers of India, it means ki you can write as A equal to, A is a set, and rivers of India like Ganga, Jamuna, Saraswati, Godavari, Narmada, etc. So, this is a set. You can say that this is a set because all the elements of the sets are well defined. So, set is defined as a collection of distinct objects of similar type, same type. For example, a set of vowels of English alphabet. So, if I say a set of vowels of English alphabet, so suppose A equal to vowels of English alphabets A, E, I, O, U. So, this is a set. On another example, we see a set of even integers, even natural numbers, set of odd natural numbers, set of positive integers, set of prime numbers, set of and so on. So, these are the sets because all elements are clearly defined. Suppose anybody say to you कि intelligent student of the class BTech first year computer science. So, is it a set? So, it is not a set because the intelligent word is not clearly defined. If I say कि intelligent are those guys who having more than 75% in a BTech first year examination, then definitely it is a set because you are at the situation to identify these are the elements, these are the students having more than 75%. So, it is a set. Suppose anybody say good batsman of the India is a set. So, no, it is not set because the good batsman, meaning of good is not clearly defined. If I say good batsman is those having more than 20 centuries in a one day and 20 centuries in a test match, so definitely you are at the situation, you are at the position to identify these are the names of the batsmen who having more than 20 centuries in a one day and 20 centuries in a test match. So, you can easily identify the elements of the set. We broadly denote a set by the capital letters. Generally, capital letters are used to represent the name of the set like A, B, C, X, Y, Z and so on. And small letters are used to represent the elements of the set. जैसे for example set of vowels of English alphabet. So the name of the set is represented by A equal to A, E, I, O, U. So this is the name of the set that is represented by the capital letters, and these are the elements of the set that is represented by the small letters A, E, I, O, U. So we denote a name of the set by the capital letters like A, B, C, X, Y, Z, and the elements of the set is represented by the small letters. If A is a set and A is one of the element of set A, here A is a set and A is the element of the set. So this can be written as A is element of A. This symbol is known as the element of या belongs to या member of या there exist. So A is element of A. Here B is not element of A. So this symbol represents a does not exist, या not element of, या not member of A. So B is not member of A. B does not belongs to A. B is not a member of A, like this. Now sets are represented in two forms. First form is known as the roster या tabulation form या tabular form. Second one is set builder form. So roster form, what is the roster form? So in this form of representation, we list all the elements of the set one by one and separated by commas and enclosed within a braces. For example, set of odd natural numbers, less than 10. So we can write set A equal to set of odd numbers less than 10 means 1, 3, 5, 7, 9. So this is known as roster form या tabulation form. It means कि the element of the set are listed one by one, separated with commas and enclosed within a braces. So this form is known as the roster form या tabular form. Second example, we say B is a set having vowels of English alphabet. So this will be A, E, I, O, U. All the elements of the set are listed one by one and separated with comma and enclosed within a braces. So this is the example of roster form या tabular form. Second notation, that is set builder form. Second representation is set builder form. In this form of representation, we list the properties fulfilled by all the elements of the set. We categorize the elements by its properties. For example, suppose A is a set that is all the Prime Minister of India. So all the Prime Minister of India, we can write in the form of set builder form X such that X is the Prime Minister of. Another example we see, if B equal to 2, 4, 8, 16 and 32, then the set builder representation is B equal to X such that X equal to 2 के power n, where n is element of n and n lie between 1 and 5, 1 and equal to 5. This is the way to write in the form of set builder representation. Now standard notations that used in set theory. This X is element of A. So X is element of A. This is element of A, yeah, belongs to A, yeah, there exists X in A, yeah, membership of A. All are synonyms. So X is element of A. This symbol. X does not belongs to A, does not belongs to set A. This is the phi, that is empty set. It means ki a set having no elements, and it is written as this way. Phi, yeah, in some cases it will be written like this. This is a universal set that is represented by the U. N, a set of natural number like n equal to 1, 2, 3 up to infinity. So all the elements are come under this natural number. The set of all integers I equal to this way, plus minus 1, 0 is also there, plus minus 2, plus minus 3, and so on. The set of all non-zero integers, it means ki excluding 0. So this will be written as I0 equal to plus minus 1, plus minus 2, plus minus 3, and all. So there is no 0. Then I plus the set of all positive integers, only positive integers are there. C, the set of all complex numbers. C naught, that is complex non-zero complex numbers, but non-zero complex numbers. 0 is not there. Q, that is set of rational numbers. Q naught, that is non-zero rational numbers. Q plus, that is positive rational numbers. R, this is the set of real numbers. R naught, non-zero real numbers, and R plus, that is positive real numbers. So these are the standard notations which are used in the set theory. Now cardinality of a set. Cardinality means the total number of unique elements, yani ki distinct elements in a set is known as the cardinality of a set. For example, A equal to 1, 2, 3, and 4. So here in the set, 4 distinct elements are there. So the cardinality of this set A equal to 4, and it is written as CARD, cardinality of A equal to 4. In some cases it is written as this way, cardinality of A equal to 4, NA equal to 4. Another way, this way we can write cardinality of A equal to 4. In any way we can write. So cardinality means unique element in a set is known as the cardinality of a set. Cardinality of the countably infinite set is countably infinite. So it means infinite sets are characterized in a two way, like countably infinite and uncountably infinite. This is a very important point. So infinite means countably infinite and incountably infinite. Uncountably infinite. So countably infinite, this is a set of even integers. Set of even integers, A is a set of even integers, so we can write 0, 2, 4, 6, 8, and so on. So countably, this is a infinite, and countably because we can map it with the one-to-one correspondence with the natural number. So natural number n equal to 1, 2, 3, 4, 6, 5, 6 onwards. So one-to-one correspondence with this set with the natural numbers, so it is a countable infinite. Uncountable infinite means we cannot do one-to-one correspondence with this element of set with the natural number. Just for example, y equal to root x, and X is element of N. So here this is X and this is Y. So X is a natural number, so we can write here 1, 2, 3, 4 and so on, and the value is Y equal to plus minus 1 plus minus root 2 plus minus root 3 and so on. So 1 is associated with plus 1 and minus 1 both. 1 is associated with plus and minus both. So this is not one to one correspondence. So this is not a countable infinite. This is the case of uncountable infinite. Is it clear? Now let us proceed. The cardinality of let P equal to KL Mn. So the cardinality of the set P is 4, and let A is the set of all non-negative even integers. So A will be 0, 2, 4, 6, 8 and 10. So this will be countably infinite because we can do one to one correspondence with the natural number. So it is the case of the countable infinite. So cardinality of this set is countably infinite. Now we will discuss here the types of set. Types of set, here we discuss finite set, infinite set, subsets, universal, proper, power, singleton set, etc. Finite set, a set is said to be finite if it contains exactly n distinct elements where n is non-negative integers. For example, set A equal to 1, 2, 3, 4, 5. So this is the case of the finite set because elements are fixed and that is to be counted by the natural number, and this is 5. So this is a case of finite sets. Another example we can say finite set, set of animals of the India, all the animals of the India. So it is a finite case, finite set because at the particular instant of time we can count it with the natural number. Set of population of the India, it is a finite set because at the particular instant we can count with the natural number. So all these are the case of the finite sets. Cardinality of the empty set. Cardinality, suppose A equal to 5. Yeah, this can be written as this. So cardinality of A equal to 0. So cardinality of the empty set is 0 and it is written as mod A equal to 0. Cardinality of even positive integer is not a finite set because suppose even positive integers की अगर बात करें 0, 2, 4, 6 and so on. So cardinality of this is not finite. It is countably infinite. Next type is infinite set. A set which is not finite is called as infinite set. For example, A equal to set of even integer. So this can be like even natural number. So this can be 2, 4, 6, 8, 10 and so on. So this is the case of the infinite set. Set of prime numbers, A equal to set of prime numbers. It means 1, 2, 3, 5, 7, 11 and so on. Set of odd numbers, natural numbers. this equal to 1, 3, 5, 7, 9 and so on. So all these are the example of infinite set. Now subsets, it's a very important subsets. If A and B are the two sets and every element of set A is also an element of set B. For example, A equal to 1, 2, 3 and B equal to 1, 2, 3 and 4. So every element of set A is also the element of set B. So we can say A is subset of B, and here B is called the superset of A. B is called the superset of A. Another example we see A equal to 1, 2 and B equal to 4, 2, 1. So set all the element of set A is also in set B. So we can say A is subset of B. Here elements of set are unordered, so it does not matter actually. So ordering is not important and repetition of the element is also not important, right? We can count only one in a set. Properties of the subsets. Every set is a subset of itself. Suppose A equal to 1, 2. So every set is a subset of itself. It means A is subset of itself. This is an important theorem. Every set is a subset of itself, and null set phi is subset of every set. These are the two important theorem that is to be remember. Every set is a subset. Every set is a subset of every set. Every set is a subset of itself, and null set is a subset of every set. Third property is, let A, B and C are the three sets and A is subset of B and B is subset of C. So we can conclude this imply A is subset of C. For example, we can say if A equal to 1 and 2, this is a set, and B equal to 1, 2, 3 and C equal to 1, 2, 3 and 4. So here A is subset of B. A is subset of B. 1, 2 are there in set A. So 1, 2 is also there in set B. So we can say A is subset of B. And similarly B 1, 2, 3 elements are there and C 1, 2, 3, 4. So B is subset of C. This imply A is subset of C. It means ki 1, 2, 3, 4 are the elements of C and 1, 2 is element of A. So 1, 2 are there in this place. So we can conclude A is a subset of C. Next, the fourth property is a finite set containing n elements has 2 k power n subsets. For example, A equal to 1 and 2. So total number of subsets of set A, subsets of A equal to phi is a subset of every set. Have you studied? A is a subset of itself. So 1 and 2 is also a subset of set A. 1 is a subset of set A and 2 is subset of set A. So by this way there are four subsets of set A. So we can conclude if n equal to 2 here, 2 elements are there in the set, so 2 ke power 2, it means ki 4 subsets are there. 4 subsets are there, and these subsets are phi 1, 2 and 1, 2. Now proper subset. A proper subset, if A and B are the two sets and A is a subset of B and A equal to B, for example, if A and B are two sets, A is said to be proper subset of B if A is subset of B and A equal to not B. The proper subset is written as A subset of B, this way. This is the symbol of the subsets and this is the symbol of the proper subset. For example, A equal to 1, 2 and B equal to 1, 2, 3. So here we can say कि A is proper subset of B because A having one element 1, 2 and B having element 1, 2, 3. 1, 2 is there but A equal to not B. So this is the case of the proper subset. It means कि proper subset, it means कि A and B, A is said to be proper subset of B, it means कि there must be at least one element in B that is not in A. So this is the example of the proper subset. Another example, see, let A equal to 2, 3, 4 and B equal to 2, 3, 4, 5. So we can say A is proper subset of B. Here there is at least one element in B that is not in A. Yani ki 5 is in B, that is not in A, and all the elements of A is in B. So we can say A is the proper subset of B. The null phi is a proper subset of every set. Improper subset, if A is a subset of B and A equal to B. A is subset of B and A equal to B. For example, A equal to 2, 3, 4 and B equal to 2, 3, 4. Here all the element of set A is in set B. So we can say A is subset of B and also A equal to B. A equal to B. So this is the case of the improper subset. Improper subset. This is not proper. This is not proper. For proper, there must be at least one element in B that is not in A. But here A is the subset of B and A equal to B. So this is the example of the improper subset. Universal set. Universal set, that is represented by the capital U, that is universal set. If all the set under investigations are subset of a fixed set U, then U is called the universal set. It can vary from situation to situation, circumstance to circumstance. For example, if we say BTech student of the Ghaziabad, BTech students of the Ghaziabad is a set A. BTech student of AKGEC Ghaziabad. So for this set A, U can be the BTech student of AK2. So this can be the universal set of this BTech student of the AKGEC Ghaziabad. If this is the set BTech students of AK2, so you can be the BTech students of all University of India be the universal set of this set BTech students of the AKTU. So it can vary situation to situation, depends upon the circumstance. Another examples we can say, in the human population studies, the universal set consists of all the people in the world. Suppose we are interested to study about the Indian population, Indian human population is a set, then the whole world population, human population can be considered as a universal set, A null set, a set having no elements, is called the null set, and it is also known as the void set, and it is denoted by phi, null set, that is denoted by this way. Example is, suppose A is a set such that X is element of n and X lies between 7 to 8, that is phi. It means that there is no elements that equal to 7, greater than 7 and less than equal to 8. X is a natural number, so this is a phi. It means that a set having no elements is called a null set, a empty set, and it is represented by phi. Singleton set, a set having only single elements is known as the singleton set. Example we can say, set A equal to X such that X is element of n and X lies between 7 to 9. So X to 9. That is, so only X equal to 8 that lies between the 7 and 9. So this is the singleton set. This is the example of the singleton set. Thank you.